This is the newly commissioned head office for one of Britain's leading construction companies, the Laing O'Rourke Group. It's a suitably handsome building for a company that is itself responsible for many impressive buildings for its clients. And it was built in just 37 weeks, from foundations to topping out. Much of this speed of construction was due to the use of a flooring system that offers a great many benefits to architects and builders in terms of larger spans, reduced crane time and faster construction, together with proven quality in design and production methods. The system is post-tensioned concrete flooring, and it was installed here on the Laing O'Rourke building by Strong Force Engineering, in origin an Australian company, now part of the Laing O'Rourke Group.
The construction activities that are happening behind me is called the installation of post-tensioning, which is a specialist form of reinforcing concrete structures, whereas we install high tensile strands into galvanised ducts and then tension those strands to induce a level of pre-compression in the slab.
Post-tensioning is a known and proven system in many countries. Here in the UK, it's best known perhaps in bridge structures. Its use in commercial and residential developments is relatively new, but increasing. So, whilst they're installing it, we can take a look at the techniques involved. The procedures are well established and simple in essence. Every operative is trained in their application and in accordance with health and safety directives. We'll pick it up just as they're landing a new coil of steel strand. It arrives in a purpose-designed pack and stands in an area cleared of obstruction and checked beforehand to ensure it'll bear the floor loading of some 3 tons. This high-strength strand will be fed into a network of ducting laid out to engineers' drawings. Working progressively from the live end, the ducts are laid out and fixed in place at the anchorages. On this project, the anchorages are within precast concrete beams. Back at the dispenser, the operatives have checked the coil numbers and they're about to feed the strand into the ducts. Shop drawings have been checked to ensure the correct number of strands are inserted in each duct. This strand pushing procedure employs 2 trained operatives, one to operate the cable pusher and the other at the far end to accommodate the jacking length. As in all site operations, safety exercises everyone's mind. If it doesn't, it should. Strong Force have a well-defined policy on the whole issue of safety, and they ensure that their operatives are fully trained in these procedures.
Prior to commencing work on a post-tension site, all of our site operatives are given a thorough safety induction on the operating procedures involved with post-tensioning, so they fully familiarise themselves with some of the potential hazards that are on a building site.
There's a different procedure for installing the shorter wire strands that run from the building perimeter. They're fed to the ducting by hand in pre-cut lengths. They'll be formed into dead ends. This is achieved by use of an hydraulic pump and jack. Before the dead ends are formed, a spacer plate has been installed to allow ingress of the concrete, together with an anti-burst spiral. Good practice is essential throughout this entire procedure of installing strands and ducts. A specified exclusion area is kept free of oils and other foreign materials. The dead ends are chaired up to the correct height and stapled to the deck. Bar chairs are fitted under the full length of each tendon to create the required profile. They too will be fixed to the deck, but not before they've been aligned. A Strong Force supervisor will check all the strands and tendons for alignment before issuing a pre-pour inspection certificate. Chairs are spaced, typically, at centres of 1 metre. They're stapled to the formwork, or, when necessary, they will be tie-wired to reinforcement bars. They now fit grout tubes to all anchors and dead ends. It's important to ensure they're long enough to stop water and debris getting in during the concrete pour, usually around 500 mil above finished concrete level. The tubes are fixed with Denso and tape. On longer tendons, vents can be installed by means of vent saddles. This marks the completion of duct installation. Next, the concrete pour. The pour is monitored to ensure that grout vents don't become blocked or damaged. Fittings will have been tightened and components secured. Workers should avoid standing on tendons and so damaging them. Operatives detailed as pour watchers give particular attention to vibrating the concrete at anchorage and dead-end locations. A Gameco machine is used for levelling, vibrating and finishing the concrete. Within 24 hours, the concrete will have cured sufficiently to carry out initial stressing. This initial stressing is done to ensure there will be no cracking in the slab when, after the concrete reaches the required compressive strength, it is subjected to final stressing. This is a time for maximum safety awareness. The 30-ton jack and its gauge have been checked and calibrated. Hoses have been examined. The work area is isolated so that only personnel directly involved are admitted. And they've been trained thoroughly in safe working practice. Anchor blocks and wedges are installed. For these 5-strand tendons, a curved cast iron block is used. 3-piece wedges are fitted around each strand and will then be pushed home all the way to the casting. A light coating of grease will have been applied to the block prior to installing the wedge. This initial operation stretches each strand to approximately 25% of the final force required. The blue paint on the strand ends establishes datum for final elongation. At a time typically 48 to 72 hours later, the concrete has reached compressive strength and is ready for final stressing. The jack, hoses and ancillary equipment will again have been checked thoroughly. They've now been stressed to the required design loading.
107, 110.
The elongation of each is measured and approval obtained to cut and seal. The protective sealer can be sprayed or brushed onto the exposed strands, barrels and wedges to stop corrosion. It's followed by a dry pack render to fill the anchorage flush with the edge beam. Time now to grout the tendons. Vents are installed and cemented in place. Batching is done on site. The mix is comprised of Portland cement to B12 grade 42.5N and an additive for viscosity. The mixer is connected by hose to a near-end grout vent. Pumping is maintained at a steady pressure. A bucket is positioned at the far end bleed tube to catch excess grout. When this tendon is filled, the tube is closed off and the procedure is repeated on the others. Grout quality is obviously important. Testing is in accordance with procedures spelled out in the method statement. Samples are analysed for characteristics including temperature and fluidity at both the mixer and the outlets. Bleed and volume tests, this is one being conducted now, will be measured over a period of 24 hours to check if water has been reabsorbed. Other tests span up to 7 days. These cube samples will be sent away to labs for analysis of the grout's compressive strength. Everything being used in these tests, the kits themselves and the polystyrene cubes, are stored carefully to prevent damage and contamination. Operatives are as thoroughly trained in these testing procedures as they are in all other aspects of the process. It is this thoroughness that makes the system one that is receiving growing approval at every level. It was used very successfully here, for example, at a building project in South London.
The procedures that you've just seen demonstrated have been effectively applied here at Salamanca Street. We've constructed two 14-storey towers for Bartley Homes. The main benefits that we've seen here is the cost effectiveness of the reduced labour and materials used on site. This has led to an ultimate 4-week reduction on our overall construction programme.
Reduced costs in labour and material, and a month ahead of schedule. That's music to many ears in the building industry.
Yes, it's a proven method nowadays. It has gained in popularity. Firstly, the engineers like it. They understand the system and the benefit it's going to give them in materials. Architects like it because it gives them freedom of expression, large open spaces and larger spans. Developers like it mainly because it saves them money and gets the building up quicker.
And that, in a nutshell, is post-tensioning.